The screen fades from black into a wide, endless horizon where the stars glimmer like ancient witnesses to secrets humanity has only begun to glimpse. A soft hum lingers in the background, not quite music, not quite silence, as though the universe itself is holding its breath. In that quiet, a question takes form, heavy yet delicate. What happens to signals when they vanish into the quantum unknown? They ripple across space, they vibrate through matter, they dance in equations, and then, without warning, they disappear. It is here, in this vanishing, that our story begins. The camera moves slowly across vast landscapes of the mind and cosmos, showing signals in different forms, a ripple spreading across a still pond before fading, a radio wave traveling through static before dissolving into nothing, the faint afterglow of a star that died billions of years ago. Each image lingers just long enough to stir curiosity, then slips away, like the very signals it depicts. The voice guiding us is calm but charged with a sense of urgency, a voice that understands the fragile beauty of chasing things destined to vanish. For centuries, humans have been obsessed with what can be seen, touched, measured, and controlled. Yet in the heart of reality, in the smallest spaces of existence, lie signals that defy these boundaries. They emerge like whispers, stay for a fleeting moment, and then dissolve back into a silence that feels infinite. Some scientists describe them as fluctuations of the quantum vacuum, others as waves collapsing when touched by observation, and still others see them as metaphors for the transient nature of all things. But no matter the perspective, the vanishing carries with it an undeniable sense of mystery. Imagine a message sent across the void of space, encoded in light, carved into radio frequencies, or hidden in neutrinos slipping through stars and planets as if they weren't there. That signal, strong when it left its source, weakens with every passing second. Perhaps it collides with dust, or stretches thin under the weight of expanding space, until one day, somewhere beyond the reach of any ear or instrument, it simply disappears. Did it die, or was it transformed into something we can no longer recognize? This question does not only belong to physics, it belongs to philosophy, to poetry, to the human spirit. The scene slows to an image of a lone scientist staring into an old oscilloscope, watching a faint trace flicker and vanish. The room is dark except for the glow of the screen. There is no dramatic explosion, no shattering revelation, only silence where once there was a signal. And yet, in that silence lies a weight, a gravity, as if the universe has stolen something back. The absence becomes louder than the presence. This is the paradox at the heart of the journey. The disappearance of signals is not emptiness, but a doorway into the unknown. Throughout history, civilizations have equated vanishing with endings. When the sun set, night swallowed the land. When a life ended, the breath vanished into air. But in science, vanishing rarely means absolute extinction. The laws of conservation whisper that nothing truly disappears. Energy, matter, even information, they may change, distort, scatter, or hide, but to vanish completely is to defy the foundations of physics. And yet, time and again, at the quantum level, signals slip from our grasp. They betray us with silence, daring us to ask whether our laws are incomplete, or whether reality itself is playing a deeper game. The mystery sharpens when we realize that vanishing is not merely a scientific phenomenon, it is also a mirror of our own existence. Every fleeting thought, every memory fading into the recesses of the mind, every heartbeat that will one day stop, each is a signal, here and then gone. In chasing vanishing signals, we are not only exploring the quantum unknown, we are also confronting the essence of impermanence that defines our lives. The tone becomes heavier here, tinged with awe and unease, pulling the viewer deeper into both science and self-reflection. But this is not a story of despair. The vanishing of signals can also be an act of creation, a clearing away that allows something new to emerge. When one signal disappears, it may give rise to another, hidden in layers we have not yet learned to detect. The story teases the audience with the possibility that what seems lost may only be beyond our current horizon of understanding. A wave disappears into silence, but does silence not hum with its own presence? A photon collapses under observation, but does it not leave behind the trace of its choice? As this opening chapter unfolds, the viewer is left suspended between certainty and mystery, between fear of loss and hope for discovery. The rhythm of the narrative is deliberate, cinematic, drawing out the tension between presence and absence. Each question raised is not fully answered, each image dissolves before completion, like signals fading before they can be fully understood. The effect is hypnotic, inviting the audience not only to learn, but to feel the gravity of the unknown. And when the final words of the section echo, what happens to the signals that vanish into the quantum unknown? The silence that follows is deliberate, heavy with possibility. The hook is set, the stage is built, and the mystery has begun. The universe is never truly silent. Even in the coldest reaches of space, even in the darkest voids between galaxies, faint signals persist. Whispers of energy, echoes of creation, threads of information so subtle they pass unnoticed by all but the most sensitive instruments. And yet, for every signal we detect, there are countless more that slip through the cracks of perception, existing just beyond the reach of our senses. These are the invisible echoes, signals that surround us like a hidden ocean, unseen but ever present, forming the quiet foundation of existence. To grasp the weight of these invisible presences, imagine standing in a vast desert at night. The wind carries grains of sand across the dunes, invisible to the naked eye but undeniable in their effect, reshaping the land grain by grain. So too do invisible signals shape the universe, flowing around us without our awareness, carrying with them the ancient history of the cosmos and perhaps even clues to its future. Each whisper in this unseen sea tells a story: the faint hiss of cosmic microwave background radiation, the subtle tremors of quantum fluctuations, the murmur of neutrinos born in the hearts of stars. They speak constantly, though few can listen. The most haunting of these signals is the cosmic background radiation, a dim glow left behind from the birth of the universe. To the untrained eye, it is nothing more than static, white noise on an old television set. But buried within that static is the memory of the Big Bang, the very first light of creation stretched thin by billions of years of cosmic expansion. It is a signal that has traveled across time itself, yet even it is fading, weakening, approaching the point where it may vanish forever. The image is both majestic and tragic, the afterglow of creation slipping quietly into silence. On a much smaller scale, quantum physics reveals another kind of invisible echo. In the quantum vacuum, particles and antiparticles flicker into existence and annihilate each other in less than a heartbeat. They are signals that appear and vanish faster than we can measure, existing in a liminal space between being and non-being. These ephemeral whispers suggest that reality itself is restless, always trembling with activity we cannot see. The thought is unsettling. If such fluctuations permeate the fabric of existence, then the very ground beneath our feet is alive with invisible motion, an eternal hum beneath the silence. The paradox deepens when we realize that invisibility is not the same as absence. Just because we cannot see a signal does not mean it is gone. Infrared light burns where human eyes see only darkness. Radio waves crash in silence through our bodies every second. Neutrinos pass through the earth like ghosts, billions of them streaming through each of us at this very moment, carrying no sound, no sight, no sensation, yet they are undeniably there. We live inside a storm of invisible echoes, a ceaseless chorus we cannot hear. The silence we perceive is, in truth, an illusion. And yet, even as we uncover these invisible presences, we are forced to face an uncomfortable truth: some signals vanish beyond recovery. Light traveling from a distant star may be swallowed by a black hole, never to be seen again. Radio transmissions sent from Earth may fade into the void, stretched and diluted until they are indistinguishable from background noise. At what point does a signal stop being a signal and become nothing at all? This question lingers like a shadow at the edge of discovery, a reminder that invisibility sometimes hides irretrievable loss. The human response to this mystery is not resignation but pursuit. Scientists build instruments of staggering sensitivity, capable of detecting signals weaker than a whisper against the roar of the universe. Antennas stretch across deserts, telescopes climb into orbit, detectors are buried deep underground, all designed to listen for the echoes we cannot hear. The sheer effort suggests something profound: humanity cannot abide silence. We search the darkness not just to find signals, but to prove that we are not alone in the void. But what if the signals we seek are not gone, merely transformed? The closing question of this section rises with the weight of revelation. Signals do not vanish in the way a flame dies. They shift, scatter, blend into forms we do not yet recognize. Perhaps the invisible echoes of today are the discoveries of tomorrow, waiting for new ways of seeing. Just as radio waves were once unimaginable, so too may there be entire oceans of information passing unnoticed through us at this very moment. The possibility thrills and terrifies. The universe is not silent, but speaking in languages we have not yet learned to hear. The section ends on a haunting image. A lone radio dish sits under a canopy of stars, its vast ear turned toward the infinite, listening not for the loud, but for the faint. The static that reaches its receiver is overwhelming, filled with noise, but buried within may be an echo, an invisible signal carrying the secrets of time, space, and reality itself. As the frame fades to black, the audience is left with the lingering question: are these signals truly gone, or simply waiting for us to learn how to listen. At the dawn of the 20th century, the world of science was bathed in confidence. The laws of Newton had stood for centuries, explaining the motions of planets and the mechanics of machines with breathtaking precision. Many scientists believed the great puzzles of the universe were nearly solved. And yet, beneath that surface of certainty, faint tremors of something stranger were already stirring. Those tremors would soon erupt into a revolution, not with the roar of cannons but with the flicker of equations, the glow of experiments, and the birth of signals no one had ever seen before. This was the birth of quantum signals, a story written not just in discovery, but in disbelief, awe, and wonder. It began with light. In the late 1800s, physicists noticed something peculiar about how light interacted with matter. The photoelectric effect, when light strikes a metal surface and ejects electrons, defied classical explanation. According to Newtonian physics, light was a continuous wave, and the intensity of the light should determine the energy of the electrons it released. But experiments revealed something shocking. No matter how intense the light, if its frequency was too low, no electrons were freed. The results seemed absurd, impossible, as though nature herself had betrayed the neat logic of classical thought. Enter Max Planck. In 1900, working late nights in Berlin, Planck wrestled with the problem of blackbody radiation, the way objects emit light as they heat. The equations of classical physics predicted a catastrophe, infinite energy spilling into the universe at short wavelengths, an absurdity dubbed the ultraviolet catastrophe. Planck's desperate solution was radical. He proposed that energy is not emitted in a smooth, continuous flow but in discrete packets, tiny indivisible quanta. With this single, almost reluctant idea, he shattered the foundations of physics. Energy, the most fundamental currency of the universe, was no longer continuous but granular, arriving like beads on a string instead of an endless wave. The consequences of Planck's idea rippled outward like a signal entering uncharted space. Just a few years later, Albert Einstein expanded on it, suggesting that light itself was quantized, that it could behave not just as a wave, but as a stream of discrete particles he called photons. With this bold step, Einstein explained the photoelectric effect, turning a frustrating anomaly into a revelation. Light could be both a wave and a particle, a contradiction that defied intuition but matched reality. In that moment, invisible signals took on new meaning. They were no longer bound to the categories of wave or particle. They were something stranger, more elusive, capable of vanishing from one form into another. The story continued with Niels Bohr, who proposed a radical model of the atom. In his vision, electrons did not orbit the nucleus like planets around the sun. Instead, they existed in discrete energy levels, and when they jumped between these levels, they emitted or absorbed quanta of light. Imagine a staircase where one cannot step halfway between rungs. The electron either exists here or there, but never in between. The atom, once thought of as a tiny solar system, was revealed to be something far more alien. The signals it emitted, the spectral lines of light, were fingerprints of these quantum leaps, clues to a reality that refused to behave according to human logic. Then came Schrödinger, who sought to describe these electrons not as particles tracing clear paths but as waves of probability. His famous equation painted the quantum world as a place of superposition, where particles could exist in multiple states until observed. To illustrate the strangeness, he conjured the image of a cat sealed in a box, both alive and dead until someone looked inside. It was not a literal proposal but a metaphor for the absurdity scientists were forced to accept. Signals, once thought to be precise and predictable, were now smeared across possibilities, flickering between realities before collapsing into one. Heisenberg soon followed with the principle of uncertainty, declaring that one could never know both the position and momentum of a particle with absolute precision. Nature itself seemed to enforce a veil of secrecy, a barrier to perfect knowledge. This was not a limitation of instruments, but of reality itself. Signals could never be fully captured, the act of measuring them changed them, like a whisper that vanishes the moment one tries to record it. The quantum world, it seemed, was designed to hide as much as it revealed. Together, these pioneers forged a new map of reality, one that was fragmented, counterintuitive, and yet astonishingly accurate. Their equations predicted phenomena that would later power lasers, transistors, and the computers guiding our lives today. But in their time, the discoveries were disorienting, almost terrifying. Imagine standing on a shoreline, watching the waves behave not like water but like ghosts, vanishing and reappearing in impossible patterns. That is how the early 20th century scientists must have felt, facing a universe that had revealed itself to be stranger than dreams. And yet, within this strangeness, a deeper beauty emerged. The vanishing and reappearing of signals, the quantization of energy, the uncertainty of measurement, all of these pointed to a truth that was not chaotic but woven with hidden order. It was as though the universe were speaking in a language of paradox, each contradiction a doorway into deeper understanding. What had begun as anomalies and accidents became the foundation of a new reality, one where vanishing signals were not mistakes but essential features of existence. As this chapter draws to a close, the narrative lingers on the image of a chalkboard covered in equations, symbols glowing faintly in the dim light of a lamp. Outside the window, the night sky stretches endlessly, filled with stars that burn with signals too faint to reach us. Inside, a mind wrestles with paradoxes that rewrite the very nature of reality. The revolution has begun, and the vanishing signals of the quantum unknown are no longer curiosities. They are the foundation of a new universe, one that challenges us to follow deeper into the dark. Particles that should be solid and dependable. Waves that should be smooth and predictable. For centuries, science divided reality neatly between these two categories, each with its own rules and logic. Particles were tiny bits of matter, like grains of sand, colliding and bouncing through space. Waves were flowing disturbances, like ripples in a pond or vibrations in the air. They belonged to separate worlds, never overlapping. Yet in the strange new territory of quantum physics, this division collapsed. The universe revealed a truth both dazzling and unnerving. Particles whisper as if they are waves, and waves vanish into the silence of particles. To feel the weight of this paradox, imagine a beam of light shining through two narrow slits onto a screen. At first, the result seems simple. If light is a particle, it should leave behind two bright stripes where the particles passed. But when the experiment is performed, a pattern of interference appears, a series of light and dark bands, like ripples overlapping in water. Light, it seems, behaves like a wave. And yet, when scientists slow the experiment down and fire one photon at a time, those photons land on the screen as if they are individual particles. Alone, each dot is unmistakably discrete. Together, they weave the fabric of a wave. This is the infamous double-slit experiment, and it continues to haunt the imagination. The deeper one looks, the stranger it becomes. If detectors are placed at the slits to measure which path the photon takes, the interference pattern disappears. The act of observation collapses the wave into a particle. Without observation, the photon exists in a haze of possibilities, exploring every path at once. With observation, it chooses only one. In this way, the signal both whispers and vanishes depending on how it is approached. Reality itself seems to hold its breath when we are not looking, then decides its form only when called upon. It is not only photons that play this dual role. Electrons, the building blocks of matter, show the same bewildering behavior. When electrons are sent through the double slit, they too interfere with themselves like waves, creating the same ghostly bands. But when measured, they collapse into localized points, betraying their particle nature. Everything we touch, every object we see, is made from electrons that defy our categories. The chair, the stone, the human body, all of it is built from entities that refuse to be only one thing. Beneath the solidity of matter lies a restless ambiguity. The paradox is more than an experiment, it is a philosophical earthquake. What does it mean for something to be both wave and particle? Is reality itself dual, or is our understanding incomplete? Some physicists suggest that wave-particle duality is simply a reflection of our limitations, a symptom of using the wrong language to describe what lies beneath. Others argue that duality is not a flaw but a fundamental feature of existence, proof that the universe resists the rigid categories the human mind tries to impose. Whatever the answer, the effect is the same. Certainty dissolves, replaced by a shimmering uncertainty that challenges every assumption. The imagery this paradox evokes is almost cinematic. Imagine a ripple traveling across a lake, then freezing mid-motion into a single droplet, suspended in space. Imagine a whisper that turns into a stone, or a shadow that transforms into a spark. Each metaphor hints at the unease of confronting a world where identity is fluid, where things are not what they seem until we force them into definition. The wave whispers possibilities, the particle declares a single outcome. Between them lies the vanishing, the transition from multiplicity to certainty, from infinite whispers to one voice. This duality also carries a deeper emotional resonance. It mirrors the human condition itself. We, too, live in superposition, potential selves, untaken paths, futures we might inhabit but never do. At every moment, observation collapses possibilities into choices, and the other paths vanish like unmeasured waves. Just as a photon is both wave and particle until observed, we are many until we become one. Science, in this sense, becomes more than physics. It becomes a mirror, reflecting back the mysteries of existence. The tension of wave-particle duality has not diminished with time. If anything, modern experiments have deepened the enigma. Larger molecules, far bigger than photons or electrons, have been shown to exhibit the same interference, as though the duality stretches far into the realm of matter we once thought was solid. This suggests that the vanishing point between wave and particle is not confined to the quantum scale but may thread throughout reality. The solidity of the everyday world may be nothing more than an illusion, an emergent effect of countless collapses hiding the underlying waves. The section closes on a haunting image, a beam of light splitting through slits, painting delicate bands on a screen, a pattern of presence and absence, visibility and vanishing. The bands shimmer faintly, as if alive, then blur and fade when observed too closely. The viewer is left with the impression of a universe that speaks in whispers and riddles, signals that flicker between forms, truths that vanish the moment we try to hold them. The paradox does not offer comfort, only a question that echoes. If even light cannot decide what it is, what does that say about the nature of reality itself? The word void has always carried with it an air of dread. In ancient times, it meant emptiness, absence, the terrifying abyss that lay beyond the known. For centuries, scientists too imagined space as a vacuum, a barren nothingness through which planets and stars drifted in silence. But as quantum physics pulled back the veil, the void revealed itself as something far stranger than absence. It is not empty, not silent, not still. It is alive with invisible tremors, restless fluctuations, and a seething energy that never ceases. To step into the quantum void is to step into a paradox, into a place where nothing is everything, where silence hums louder than any noise, where vanishing becomes the most fertile act of creation. Imagine for a moment standing in a vast cathedral of darkness, stretching beyond sight in every direction. At first it seems empty, a stillness so pure it feels sacred. But as your eyes adjust, you notice movement, tiny flickers of light sparking and vanishing, ghost-like ripples appearing and dissolving before they can even be named. This is not imagination, it is the truth of the quantum vacuum. Even at absolute zero, the coldest temperature possible, where all thermal motion ceases, the void does not rest. It crackles with activity, with virtual particles that burst into existence and vanish in an instant, never lingering long enough to be measured directly, yet shaping the universe in ways that cannot be denied. These fluctuations are not trivial curiosities. They are the foundation of the cosmos itself. The forces that hold atoms together, the stability of matter, the very fabric of spacetime, all are influenced by the invisible churning of the vacuum. Physicists call this zero-point energy, a term that fails to capture its poetry. It is the energy of emptiness, the eternal hum that ensures there is no such thing as nothing. Every corner of the universe is filled with it. The vacuum is not a stage upon which reality plays, it is itself a restless actor, shaping the script in silence. Yet this truth is deeply unsettling. If the vacuum seethes with energy, why does the universe not explode with it? Calculations suggest that the energy density of the quantum vacuum should be unimaginably vast, enough to tear spacetime apart. And yet, what we observe is calm stability. The discrepancy is so extreme it has been called the worst prediction in physics, a clash between quantum mechanics and general relativity that leaves scientists both humbled and haunted. The void is fertile with energy, but it hides its true face, offering only glimpses and contradictions. It is a riddle that mocks our equations, a silence that hums with laughter. The imagery of the void often carries the weight of cosmic horror, not because it is evil, but because it resists comprehension. We imagine monsters lurking in the abyss, yet the real monster is our own ignorance. The quantum void is stranger than any myth, a sea of particles that exist for less than an instant, borrowing energy from nothing and returning it before they can be caught. This endless dance raises unsettling questions. If particles can appear from the void, could entire universes do the same? Is our cosmos itself just a fluctuation that blossomed out of nothingness, a quantum echo stretched into infinity? The idea chills and fascinates in equal measure. What we call something may simply be the froth of the void, a crest in an infinite sea of fluctuations. And just as waves rise and fall, so too could universes emerge and vanish, ephemeral sparks in the darkness. In this light, the void is no longer empty, it is the womb of reality, the hidden wellspring from which existence itself is born. The section shifts in tone, slowing to let this realization sink in. Every breath we take, every particle that makes up our bodies, every star that burns in the sky, all of it rises from a void that never sleeps. To call it nothing is an insult, it is the deepest something we have ever glimpsed. And yet, Because it hides beneath invisibility, it unsettles us. We prefer solid ground, certainty, permanence. But the void offers none of these. It offers only restless motion, signals that vanish before they can be known, truths that collapse into silence before we can name them. And still, there is beauty. The void is not merely a place of terror, it is also a place of possibility. The same fluctuations that bewilder us also give rise to phenomena like the Casimir effect, where two plates placed close together feel a mysterious force pulling them together, born of the restless energy of the vacuum itself. In laboratories, this invisible hum has measurable consequences, proof that the void's whispers touch even the tangible world. The silence speaks, if we learn how to listen. As the section nears its close, the imagery turns cinematic once more. Picture the universe in its infancy, less than a fraction of a second old, when quantum fluctuations in the void seeded the galaxies that would one day become home to stars, planets, and life. From nothing, everything. From vanishing signals, the architecture of the cosmos. The void is not absence, but origin. It is both the shadow and the spark, the abyss and the womb. The final words linger in a tone of awe mixed with unease. The void is not where signals go to die, but where they go to be reborn. To peer into it is to confront both the terror of vanishing and the wonder of emergence. The silence of the void is louder than thunder, a reminder that emptiness is the greatest illusion of all. In science, we are taught to believe that everything can be measured. With better tools, sharper instruments, and more precise equations, the hidden details of the universe will eventually yield themselves to us. Yet, in the realm of the quantum, this belief collides with an unsettling truth: some signals cannot be captured. They vanish not because they are weak or distant, but because reality itself refuses to allow them to be pinned down. This is the strange domain of Heisenberg's uncertainty principle, a law that reveals a boundary not of technology, but of existence itself. Here, measurement is not merely limited, it is haunted. Imagine trying to listen to a faint whisper in a storm. The harder you lean in, the more the storm itself drowns it out. The act of trying to hear destroys the signal you seek. On the quantum scale, this is not metaphor but reality. A particle's position and momentum, the two most basic descriptors of its existence, cannot both be known with perfect accuracy. To measure one with precision is to blur the other into uncertainty. The signal vanishes under the weight of observation, like a candle's flame blown out by the very act of trying to touch it. The implication is staggering. It means there are aspects of reality forever closed to us, not because we lack the right instruments, but because the universe itself enforces a veil of secrecy. The uncertainty principle is not an accident, it is a built-in feature of the quantum world. Nature whispers, but not all whispers can be heard. Some dissolve the moment we try to grasp them. This limitation reshapes the very philosophy of science, reminding us that to observe is not to stand outside reality, but to intrude upon it, to disturb the fragile balance of the signals we seek. The imagery of vanishing signals plays out most vividly in experiments. Consider again the double-slit experiment, but this time with the attempt to measure the exact path of a particle. Each attempt to lock down its journey erases the interference pattern, collapsing the wave of probabilities into a single, definite point. The particle's whispering possibilities vanish, replaced by a blunt certainty. What is gained is clarity, but what is lost is the infinite spectrum of maybes that once shimmered around it. The very act of looking silences the song. For scientists, this is both a source of frustration and wonder. On one hand, it imposes limits on our quest for complete knowledge. No matter how advanced our detectors become, no matter how refined our theories grow, some signals will always remain out of reach. On the other hand, it suggests that reality itself is participatory, that we are not neutral observers, but entangled players in the drama of existence. Each measurement is an interaction, a dialogue between observer and observed, where both are changed. The universe does not sit idly by while we interrogate it, it reshapes itself in response to our gaze. This notion carries with it a quiet terror. If reality resists being fully measured, then how much of what we call truth is only an approximation? How much slips through the cracks of uncertainty, vanishing before we can write it into equations or trap it in data? The uncertainty principle whispers that every measurement we make is a compromise, a trade-off between what we learn and what we lose. To know one thing is to allow another to fade into invisibility. Knowledge itself becomes a balance of vanishing and appearing, a dance of signals forever beyond completion. And yet, within this haunting truth lies possibility. Uncertainty is not only limitation, it is also the source of quantum creativity. Without uncertainty, atoms could not form the stable structures that give rise to matter. Without vanishing signals, reality would collapse into rigid determinism, leaving no room for novelty or emergence. The unpredictability that frustrates physicists is also what allows stars to burn, life to evolve, and consciousness to flicker awake. The vanishing of signals is not merely loss, it is the heartbeat of creation. The cinematic weight of this paradox comes alive when we step back to see its broader implications. Imagine the cosmos as a grand symphony, every particle a note, every interaction a chord. Yet no listener can ever hear the entire piece at once. Some notes vanish into silence when others sound, some harmonies dissolve the moment we strain to capture them. What we experience is always partial, always incomplete. The full song exists, but forever beyond the range of human ears. This is both humbling and exhilarating, a reminder that mystery is woven into the structure of existence. The section closes on a stark image. A scientist leans over a glowing instrument in a darkened lab, straining to capture the faintest signal. The machine hums, lights flicker, numbers scroll across screens. For a moment, a trace appears, a flicker of presence, and then it vanishes, gone before it can be held. The silence that follows is not failure but truth. Reality itself has drawn its boundary, reminding us that to measure is to participate, and to participate is to lose as much as we gain. What disappears when we look? What vanishes when we seek? The uncertainty principle does not answer, it only deepens the question. And in that deepening lies the enduring allure of the quantum unknown. In the theater of science, no stage is more mysterious than the laboratory where quantum entanglement is tested. Here, under the hum of cooling systems and the sterile glow of precision lasers, physicists attempt to capture one of nature's most haunting phenomena, the instant, invisible communication between particles separated by vast distances. It is here that Einstein's disquiet resurfaces, where his famous dismissal, spooky action at a distance, takes on flesh and form. What he considered absurd, the world now confronts as reality. The signals, if they can be called that, leap across space with no regard for time, no respect for the cosmic speed limit of light. They appear, vanish, and reappear, as though mocking our most cherished laws. Imagine two photons, born together in a single spark of light, then torn apart and sent to opposite ends of the earth. When one is measured, its partner instantly reveals a corresponding value, as though connected by an invisible thread beyond space itself. No signal travels, no messenger carries the news, yet the outcome is as synchronized as a mirror reflection. In this experiment, distance becomes meaningless, and our classical picture of a local universe begins to crumble. The particles whisper to each other across the void, or perhaps they were never truly apart to begin with. The laboratory becomes a stage for philosophical unease. Physicists arrange their detectors with obsessive care, chasing correlations with statistical rigor. And when the results appear, they are as haunting as they are undeniable. The measurements confirm entanglement again and again. Reality is not composed of isolated fragments, but of connections that defy separation. Each experiment is like a ritual invocation, summoning proof that the universe is woven from relationships, not parts. Yet with each confirmation, another question rises: what is the medium of this vanishing signal? What invisible thread binds these distant particles? Einstein could not accept it. For him, the notion that entanglement was real suggested that the universe tolerated faster-than-light influence, something he believed impossible. He insisted that there must be hidden variables, unseen instructions buried deep within the particles from the moment of their creation. To him, entanglement was not communication, but a trick, a card game where the outcome was decided in advance, and the illusion of instant connection was nothing more than sleight of hand. But experiment after experiment began to erode this defense, showing that no hidden variables could fully explain the correlations. The spooky action was not illusion, it was reality itself speaking in riddles. The tension between Einstein's protest and modern evidence forms one of the great dramas of science. On one side stands the classical dream, a universe governed by local causes, where information can travel only as fast as light. On the other stands quantum reality, where boundaries dissolve, and distance is no barrier. Between them stretches a chasm of interpretation, filled with wonder and unease. For if entanglement is true, then the world is not a stage of separate actors, it is a single, indivisible performance. What happens in one corner reverberates instantly in another, even across the stars. The cinematic imagery of entanglement reaches beyond the lab. Picture two astronauts, drifting on opposite sides of the solar system, yet each holding a particle entangled with the others. When one astronaut measures theirs, the other particle instantly reveals its complementary state, as though the vacuum of space were merely a thin veil. Such images fuel not only scientific inquiry but cultural imagination. Science fiction seizes on this idea, envisioning communication networks faster than light, or even consciousness itself entangled across minds. But the truth is stranger than fiction. Entanglement does not allow us to send messages at all. The signal vanishes as soon as we try to control it, dissolving into randomness. The connection is real, but it cannot be harnessed for command. It whispers of unity without offering mastery. This paradox deepens the philosophical wound. If entanglement cannot be used to send signals, then what kind of reality does it represent? Is it evidence that space and time are illusions, that what we call separation is merely a projection of a deeper oneness? Or is it simply a quirk of mathematics, a coincidence written into the rules of quantum probabilities? The experiments prove that entanglement exists, but they do not reveal what it means. The vanishing signal leaves only questions in its wake, echoing louder for their lack of resolution. And yet, for all its mystery, entanglement carries a strange beauty. It suggests that the universe is not a machine of cold gears, but a tapestry of shimmering threads, each thread woven with another in patterns too subtle for human eyes. It speaks of intimacy at a distance, of a cosmos where nothing is truly alone. In this vision, the laboratory becomes not just a site of measurement, but a temple where the hidden unity of existence flickers briefly into view, before vanishing again into silence. As the section closes, the image returns to the physicists themselves, men and women staring at screens filled with numbers, graphs, and probabilities. Their faces are lit by the glow of data, but behind their eyes burns something deeper, a confrontation with mystery. They are not simply measuring particles, they are peering into the seams of reality, where distance collapses and connection reigns. The question that lingers is not whether entanglement is real, it is. The haunting question is what it tells us about the very structure of the universe. Are we seeing the first glimpse of a deeper order, or merely brushing against the limits of human comprehension? What is the nature of this silent thread? What kind of signal vanishes the moment we try to control it, yet persists in the shadows of probability? The lab cannot answer. The equations cannot decide. And so, the mystery remains, spooky, haunting, and irresistibly real. In the heart of every mystery lies an image that lingers long after the words have faded. For the quantum world, that image is the wave function, a ghostly pattern of possibilities, stretching like a cloud across the unseen dimensions of reality. It is not a solid thing, not a particle in motion, but a mathematical description of where a particle could be, what it could do, how it could exist. It is probability woven into form, a tapestry that shimmers with infinite outcomes. And yet, the moment we try to touch it, the tapestry collapses into a single thread, one possibility chosen, all others vanishing like dreams upon waking. This collapse is one of the most unsettling phenomena in modern physics. Before observation, the particle is not here or there, not spinning this way or that, it is suspended in a haze of maybes, a superposition where all futures coexist. But when the act of measurement intrudes, the wave function reduces, collapsing into one reality while erasing all the others. The many possible signals vanish into a single certainty, and with them goes the haunting richness of quantum ambiguity. It is as though the universe refuses to reveal more than one outcome, forcing us to watch a grand performance through a keyhole. The cinematic weight of this collapse cannot be overstated. Imagine a corridor lined with countless doors, each one leading to a different reality. For the particle, all the doors are open at once, until observation arrives. Then, in an instant, every door slams shut except one, and we find ourselves staring into the narrow path that remains. What lies behind the other doors? We can only speculate. They are gone, lost in the act of measurement, their signals forever silent. Here, science meets philosophy head-on. The collapse of the wave function is not simply a technical process, it is a confrontation with the limits of knowledge. Is the collapse real, a physical event in which the universe itself chooses a single outcome? Or is it merely an illusion, a reflection of our ignorance, the moment when our description of reality catches up with what was always true? Physicists and philosophers divide sharply. Some insist that the collapse is nature's decision, others argue it is ours, a projection of our limited perspective. In either case, the mystery deepens. The imagery of vanishing signals becomes hauntingly clear in this context. Before observation, the signals of possibility spread out like ripples on a pond, stretching into every direction, carrying echoes of futures we cannot see. But as the observer arrives, those signals dim, canceling each other out until only one remains. The others vanish into silence, not because they were false, but because they were never allowed to speak. The collapse silences them. The observer becomes executioner, deciding which futures will live and which will die. For some, this raises terrifying implications. If observation collapses the wave function, then does consciousness itself play a role in shaping reality? Are we, by looking, by measuring, by knowing, responsible for choosing the universe we inhabit? If so, then the boundary between mind and matter dissolves, leaving us entangled not just with particles, but with the fabric of reality itself. Each act of observation would then be more than passive recording, it would be an act of creation. The universe would not be merely discovered, it would be called into being. Others resist this conclusion, preferring to imagine hidden mechanisms or parallel worlds. Perhaps, they argue, the other possibilities do not vanish at all. Perhaps they persist, branching into new universes where each unrealized outcome becomes realized elsewhere. In one universe, the particle is here, in another, it is there. In one, the cat lives, in another, it dies. The wave function collapse becomes not a destruction of futures, but a proliferation of them, each vanishing from our sight while continuing elsewhere. What vanishes here may still whisper in another cosmos. The laboratory remains the crucible of this debate. When detectors click and graphs draw lines across screens, physicists see only the final outcome. The probability cloud vanishes, leaving behind a single data point, a lonely survivor of infinite possibility. Yet behind that point lies the ghost of the wave function, a memory of what might have been. Each experiment is haunted not only by what is measured but by what is lost, the infinite futures denied in the name of one realized signal. For the audience of this cosmic drama, the wave function collapse offers a profound metaphor for human existence. Each choice we make, each action we take, collapses the possibilities of our lives into one unfolding story, while countless others fade into silence. The roads not taken, the lives not lived, the words not spoken, all vanish like quantum possibilities denied by observation. We are each, in our way, the collapsing wave function of our own destiny. And so, the question remains, burning at the edges of science and philosophy, is the collapse real, or is it only a trick of perception? Are the vanishing signals truly gone, or do they echo somewhere beyond our reach, in dimensions hidden from sight? The laboratory offers data but no answers. The equations describe the collapse but do not explain it. The mystery persists, sharp as ever, reminding us that the quantum world is not a puzzle to be solved but a riddle to be lived. The section ends with a haunting image, a glowing cloud of probability suspended in darkness, shimmering with countless possibilities. Then, a flash, an observation, and the cloud vanishes, leaving behind a single spark. The silence that follows is unbearable. What futures have been erased? What realities have been lost? The wave function collapse offers no reply, only the stark reminder that in the quantum world, to know is to destroy, to measure is to erase, and to observe is to collapse the infinite into the finite. In the classical world, signals travel with a comforting reliability. A shout echoes across a canyon, a radio wave hums across continents, a beam of light streaks across the stars at a speed we can measure and trust. Information flows like water through a riverbed, steady and predictable. But in the quantum world, this familiar rhythm is shattered. Signals do not always behave like messengers carrying clear meaning. Instead, they flicker, distort, and in many cases, vanish into uncertainty. At this scale, the very concept of a signal becomes slippery, blurring into something that resembles a whisper in an unfamiliar language, half heard, half imagined, never fully delivered. The paradox is sharpest when we consider quantum communication. Entanglement promises a kind of connection beyond space, but it denies us the ability to control it. We cannot use entanglement to send a message faster than light, no matter how desperately we try. The instant correlation is real, but it is mute, it refuses to carry a signal we can choose, encode, and decode. It is a presence without a voice, a link without content. To the physicist, this is frustrating. To the philosopher, it is profound. The universe allows connection, but not command. It offers intimacy, but withholds control. Here the imagery turns cinematic. Imagine standing in a vast field of stars, holding a radio tuned to the cosmos. At first, the static seems random, a meaningless hiss. But hidden within the noise are faint harmonies, patterns that reveal themselves only in fragments, vanishing as soon as they appear. This is the nature of quantum signals. They are not the bold broadcasts of classical physics but elusive apparitions, hovering on the edge of detection, mocking our desire for clarity. To listen is to confront absence as much as presence. This paradox forces us to ask unsettling questions. What does it mean to communicate if no message is truly sent? If entangled particles mirror each other without exchange, then what is happening between them? Is it that information is traveling faster than light, breaking the rules of causality? Or is it that information was never sent at all, but has always been shared, as though the two particles are not two but one, their separation an illusion born from our limited view? The debate circles back to Einstein and Bohr, those towering figures who wrestled with this mystery. For Einstein, the refusal of entanglement to carry signals was proof that something was missing in quantum theory, hidden variables, secret mechanisms, something lurking beneath the probabilities. For Bohr, the silence of the quantum signal was not a failure but a feature. The quantum world, he argued, does not need to fit our classical language of transmission and reception. It is not about sending messages across space, but about revealing the deep non-locality of existence itself. To Bohr, the vanishing signal was not a weakness, it was the very essence of quantum truth. In laboratories today, this paradox fuels both frustration and innovation. Quantum cryptography, for example, relies on the strange silence of entangled signals. Because no usable message can be forced through entanglement, any attempt to eavesdrop is immediately revealed by the disturbance it causes. The vanishing signal becomes a shield, a guardian of secrecy. Out of the silence, new possibilities for security emerge. What once seemed like a failure becomes a tool, proof that the universe hides as much as it reveals. Yet the unease lingers. If entangled particles do not transmit signals, what, then, binds them together? If no message passes, how can two distant objects respond as one? The silence itself becomes the mystery. It is as though reality is whispering, but in a tongue so alien that translation is impossible. We hear the harmony but cannot extract the words. We glimpse the connection but cannot grasp its medium. The signals appear, vanish, and leave us with the ache of questions unanswered. The metaphor extends beyond science into the human condition. How often do we feel connected to someone across distance without words, without messages? How often does silence itself carry meaning, a presence that cannot be explained but is undeniably real? In this way, quantum communication becomes a mirror of human intimacy, connection without transmission, closeness without exchange. The universe, it seems, operates on levels that echo our deepest experiences of presence and absence. The cinematic close of this section returns us to the lab. A physicist sits before entangled detectors, staring at streams of data. Each measurement confirms the paradox. The particles mirror each other, yet no signal passes between them. It is like watching two dancers move in perfect sync across a stage, though no music plays. The physicist's face is lit with awe and frustration, the glow of discovery mixed with the shadow of ignorance. In the silence of the vanishing signal, the deepest questions of existence continue to hum, just beyond the reach of comprehension. What is a signal that carries no message? What is a connection that cannot be controlled? In the quantum world, silence speaks louder than words, and the vanishing signal becomes the most eloquent of all. To speak of reality as though it were solid, continuous, and dependable is to speak in the language of the classical world. There, the apple falls, the pendulum swings, and the planets obey their orbits with unwavering precision. The signals are strong, unambiguous, and comforting. But in the quantum world, this assurance evaporates. Reality itself seems fractured, suspended in probabilities, whispering in riddles rather than declaring its truths. The signals we seek are fragile, partial, and often gone before we can hold them. This clash, between the solidity of the classical and the slipperiness of the quantum, is more than a technical problem. It is a philosophical earthquake. The transition between these two worlds forms one of the most cinematic contrasts in all of science. Imagine standing at the shoreline where two oceans meet, one calm, predictable, and sunlit, the other chaotic, stormy, and unfathomable. The line between them is blurred, constantly shifting, and yet undeniable. On one side, Newton's equations guide rockets into space and clocks keep time with uncanny accuracy. On the other, wave functions shimmer with infinite possibilities, particles vanish into uncertainty, and signals collapse into silence. To move from one world to the other is to cross a boundary where certainty dissolves into mystery. At the heart of this contrast lies the question, how does the quantum become the classical? If atoms and electrons obey quantum rules, then why do apples and mountains not shimmer in probability clouds? Where, exactly, does the collapse occur? Some argue that it happens at the level of measurement, that when the quantum system interacts with a macroscopic observer, its shimmering haze crystallizes into the solid world we know. Others argue that decoherence, the process by which quantum systems interact with their environment, washes away the quantum weirdness long before we notice it. But no consensus exists, and the paradox remains like a ghost at the edge of understanding. The imagery of vanishing signals sharpens here. At the quantum scale, possibilities bloom like constellations across the sky. Yet by the time they scale up into the macroscopic, those stars go dark, leaving only a single outcome visible. The signals vanish in the transition, erased by the sheer weight of the classical world. It is as though the cosmos tolerates ambiguity only in the shadows, never in the spotlight of human experience. And yet, the shadows are where the deepest truths reside. Philosophers seize on this divide, seeing in it not only a scientific puzzle but a challenge to our most basic assumptions about reality. If the world is quantum at its core, then the classical world we inhabit is not fundamental, it is a veneer, an emergent surface hiding a turbulent depth. What we call real may be nothing more than a stable illusion, a consensus formed from collapsing probabilities. The apple falls not because gravity is simple, but because countless vanishing signals beneath its atoms have already collapsed into order. Reality, in this vision, is not a foundation but a performance, maintained moment by the disappearance of quantum uncertainty. And yet, for all its instability, this performance works. The macroscopic world is reliable enough to build civilizations, launch satellites, and compose symphonies. The paradox is that the solidity of the classical rests on the fragility of the quantum. The vanishing signals are not failures but sacrifices, possibilities surrendered to give us the stable reality we need to survive. In this sense, the silence of the quantum world is the background hum upon which the music of everyday life is played. This tension carries emotional weight. On the one hand, it reassures us, the floor beneath our feet will not dissolve into probability clouds, and the sun will rise tomorrow with dependable grace. On the other hand, it unsettles us. Beneath that stability lies a world that refuses solidity, a universe that withholds its truths and hides its signals in shadow. We walk across a surface of stone, but beneath the stone lies quicksand. For scientists, bridging the gap between quantum and classical is one of the grand quests of modern physics. Experiments now attempt to push larger and larger objects into quantum states, to make molecules, or even small mechanical systems, exist in superposition, shimmering like particles. Each success blurs the boundary further, suggesting that the quantum does not stop at the microscopic, but underlies everything. The question is not whether the classical emerges from the quantum, it must, but how the signals survive the transition, and why most vanish before reaching the macroscopic world. The metaphor extends naturally to human experience. We, too, live suspended between worlds, one of solid certainty, where routines and patterns anchor us, and another of ambiguity, where choices, possibilities, and uncertainty swarm. Just as the quantum collapses into the classical, our lives collapse into single outcomes, erasing the many futures we once held. Each decision silences possibilities, each step forward vanishes countless alternatives. We live, in essence, as wave functions collapsing into stories, our reality sculpted from probabilities into certainties. The section closes on a striking image. A scientist holds a pendulum, watching it swing back and forth with timeless predictability. Behind her, on the lab bench, a quantum experiment hums softly, its detectors alive with uncertainty. Two worlds coexist in the same room, yet separated by a chasm of scale and understanding. The pendulum whispers certainty, the detectors whisper vanishing signals. Between them lies the unanswered question that defines modern physics: how does one become the other? What is the bridge between the solid and the spectral? Where do the vanishing signals go when they collapse into certainty? The answers remain hidden, and the silence of that mystery speaks louder than the ticking of any clock. Time is supposed to be the most faithful of all signals. It marches forward with unwavering rhythm, measured by the swing of pendulums, the ticking of atomic clocks, and the slow decay of radioactive elements. In the classical world, time is an arrow, straight, steady, irreversible. But in the quantum world, this arrow begins to bend. Signals of time do not always behave as expected. Sometimes they stretch, sometimes they flicker, and sometimes they vanish altogether. What we think of as the bedrock of existence begins to reveal fractures, as if time itself is not a constant flow but a fragile construct. To enter the quantum domain of time is to walk into a labyrinth where direction and order lose meaning. Imagine watching a film reel where scenes play forward, then suddenly in reverse, then forward again, yet the story somehow continues. On the scale of particles, time seems less like a river and more like a restless tide, moving not only forward but sideways, even backward, erasing distinctions we once thought eternal. Particles and quantum experiments do not respect our human sense of before and after. In some cases, Cause and effect blur until they are indistinguishable, leaving us to wonder if the future might influence the past as much as the past influences the future. One of the most haunting examples comes from the delayed choice experiment, inspired by John Wheeler. In it, a particle appears to decide whether it traveled as a wave or a particle only after the experimenter has chosen how to measure it, after the fact. It is as though the present moment reached back and rewrote the past, deciding retroactively what the particle had done. The signal of time vanishes, replaced by a loop that resists linear explanation. If time is a story, then the quantum world scribbles in the margins, rearranging sentences after the book has already been written. Such results challenge not only physics but philosophy. If the arrow of time can bend, then what does it mean to speak of causality? Our daily lives are built on the assumption that events follow one another in sequence. The match strikes, the flame appears, the seed is planted, the tree grows. But at the quantum level, such chains blur. Perhaps time is not an arrow at all but a tapestry, where threads of past, present, and future are woven together, influencing one another in ways our minds cannot easily grasp. The vanishing of time signal suggests that what we call now may be an illusion, a convenient slice of a reality that exists all at once. The imagery here grows cinematic. Picture a hallway lined with mirrors, stretching endlessly in both directions. In one mirror, you see your reflection moving forward, in another, you see it walking backward. Both images exist simultaneously, each as valid as the other. Which is the true you? The quantum world offers no answer, only the unsettling possibility that both are real, until observation collapses the ambiguity into a single flow. Time, in this vision, is less a highway and more a fog, where signals emerge briefly and then dissolve, leaving us unsure of which way we are moving. Physicists attempt to tame this mystery with mathematics. Equations such as Schrödinger's are time-symmetric, they allow motion both forward and backward. It is only when collapse enters the picture, when measurement occurs, that time seems to acquire direction. This raises the possibility that the arrow of time is not fundamental at all, but emergent, an illusion born from the vanishing of possibilities, from the silencing of alternative pathways. Entropy, the measure of disorder, provides one explanation. Time feels like it moves forward because entropy tends to increase. But even entropy bows to quantum uncertainty, and in certain situations, the second law itself seems to blur. For those seeking meaning, the idea that time is malleable cuts deep. It suggests that what we call the past may not be locked, that what we call the future may already exist in some form, waiting to be revealed. The human heart, with its longings and regrets, feels the weight of this possibility. If signals of time vanish, then what becomes of memory, choice, or destiny? Are we truly moving along a line, or are we simply collapsing one possibility after another from a timeless whole? This uncertainty fuels both fear and awe. Fear, because it destabilizes the very structure upon which we build meaning, beginnings, middles, and ends. Awe, because it opens the door to possibilities beyond imagination, realities where time is not linear but layered, where the past can be rewritten, where eternity is not endless duration but simultaneous presence. The vanishing signals of time suggest that the universe may not be a clock but a canvas, and we are glimpsing only fragments of its painted surface. The cinematic close of this section returns us to a haunting image. In a darkened laboratory, a laser pulse flickers through an apparatus designed to test the delayed choice experiment. The detectors click, and data scrolls across screens. To the human eye, the event is instantaneous, cause followed by effect. But in the mathematics, something stranger lurks. The choice made now seems to ripple backward, rewriting what was moments ago. The physicist watching is silent, caught between wonder and dread, knowing that time itself has been unsettled. What is time if its signals can vanish? What is memory if the past itself is not fixed? The quantum world refuses to answer. Instead, it leaves us suspended, like particles in superposition, between certainty and mystery. Space has always been imagined as a vast stage, silent and obedient, upon which the drama of the universe unfolds. Stars burn, galaxies spin, and planets orbit, all moving across an invisible backdrop that seems eternal and unchanging. But the quantum perspective shatters this comforting vision. In the depths of physics, space is not a passive arena but an active, restless participant. Its signals, those faint whispers that tell us where things are, how far apart they might be, begin to vanish when examined too closely. Distances blur, locations dissolve, and the very concept of here and there collapses into ambiguity. What we thought was firm and measurable becomes as elusive as a mirage shimmering on a desert horizon. Imagine zooming in on the smallest scales of existence, far below atoms, below even quarks, down to the suspected fabric of spacetime itself. At this level, space is not smooth but frothing, like an ocean in a storm. Quantum fluctuations churn restlessly, constantly reshaping the geometry of reality. Points no longer have fixed positions. Instead, they fluctuate in a haze of probabilities. A particle may be here, or there, or both, until an observation forces it into one outcome. The signal of space, its coordinates, its distances, fades into silence. What emerges is not a landscape of definite structure but a fog of uncertainty. This breakdown is most clearly revealed in the phenomenon of quantum tunneling. A particle confined within a barrier, according to classical logic, should never escape. Yet it does. Without warning, without explanation in traditional terms, it appears on the other side as though space itself had temporarily loosened its grip. The signal of separation, of boundary, has vanished. Space does not confine, it yields. To us, it feels miraculous. To quantum reality, it is ordinary. Every time this occurs, it whispers a warning. The distances we measure and rely upon are fragile, not fundamental. Even Einstein's relativity, so precise in its description of curved spacetime, is shaken here. At the Planck scale, where quantum mechanics and relativity collide, our equations collapse. Space becomes foamy, fragmented, unpredictable. What we perceive as the continuous expanse of the cosmos may in fact be a granular fabric, woven from tiny quanta of geometry. Like pixels on a screen, these units vanish when we step too close, dissolving into abstraction. The very stage of the universe may not be infinite but constructed, emergent, and uncertain. Philosophically, this is devastating and liberating at once. For centuries, humanity has sought security in the notion of place, the home, the land, the cosmos itself as a container. To learn that space may not exist as a fixed entity is to confront existential vertigo. Yet it also sparks awe. If the signals of space vanish, then perhaps we are not confined to a rigid structure at all. Perhaps reality is more flexible than we ever dared to dream, capable of bending and reforming in ways that defy human imagination. One haunting image captures this paradox, a map fading as you walk across the territory it describes. Roads, rivers, mountains, all dissolve behind you, leaving only fragments ahead. You move forward, yet there is no certainty that space itself exists until you arrive. The universe becomes not a pre-drawn canvas but a self-unfolding story, where the act of traveling writes the road beneath your feet. This mirrors the quantum principle of locality dissolving, the idea that objects are not firmly anchored in space, but their relations and entanglements create the illusion of location. Entanglement itself deepens the mystery. Two particles, separated by vast distances, behave as though no space divides them at all. Their states are linked, instantaneously, beyond any signal we can measure. Einstein called it spooky action at a distance, but perhaps the real spookiness lies in the suggestion that distance itself is not real. If two particles can remain united across galaxies, then space as separation may be nothing more than a veil. When the signals of space vanish, what remains is connection, not across space, but in defiance of it. For physicists, this challenge is both thrilling and maddening. Experiments push ever deeper, probing the smallest scales with particle colliders and high-energy lasers, searching for evidence of space's granular nature. Meanwhile, theories such as loop quantum gravity and string theory attempt to reconcile the contradictions, painting pictures of a universe built not upon continuous extension but upon vibrating strings, networks of loops, or holographic projections. Each model suggests that what we perceive as space may be nothing more than an emergent phenomenon, a shadow cast by deeper, hidden laws. The emotional resonance of this idea cannot be ignored. To stand beneath the night sky and feel the vastness of space is one of the oldest human experiences. Yet now we are told that this vastness may be an illusion, a construct that dissolves under scrutiny. It is both terrifying and liberating. Terrifying, because it strips away the stage upon which our lives unfold. Liberating, because it suggests that reality is not bound by limits we once thought absolute. Space may vanish, but in its disappearance lies the possibility of something greater, a reality where location, distance, and boundary are not constraints but possibilities waiting to be defined. As this section closes, the cinematic image is one of dissolution. A grid of glowing coordinates stretches across the screen, defining a perfect geometric plane. Slowly, the lines flicker, fade, and vanish, leaving only darkness. Then, in that darkness, 2 points of light appear, separated at first, then pulsing as one, united beyond distance. The signal of space is gone, but connection remains, whispering a deeper truth. And so the question lingers, if the signals of space can vanish, what is the true fabric of reality? Are we moving through a cosmos of distances and locations, or through something more elusive, a hidden order where space itself is not fundamental, but fleeting? Energy, like a river, flows through the universe, animating matter, stirring fields, and igniting stars. In classical physics, it is predictable, measurable, and conserved, a ledger that balances perfectly across time and space. But at the quantum level, energy reveals a far stranger character. It flickers, appears, and vanishes without warning. Particles borrow it from the vacuum itself, perform ephemeral feats, and then return it before anyone can measure their transaction. These are not anomalies, they are fundamental expressions of reality. The signals of energy, like whispers in the dark, are fleeting, vanishing before full comprehension, yet shaping the cosmos in ways both subtle and profound. Consider virtual particles, entities that exist for infinitesimal moments, popping into existence from the void and disappearing almost immediately. They cannot be observed directly, yet their presence is undeniable. They leave fingerprints on reality, altering forces, nudging particles, influencing the behavior of matter. The Casimir effect, where two metal plates attract in a vacuum due to the unseen pressure of virtual particles, is a direct manifestation of this restless energy. What vanishes before our eyes is precisely what produces measurable consequence. Energy signals are not gone, they are hidden, ephemeral, and woven into the tapestry of the universe. The cinematic imagery of this phenomenon is striking. Picture a dark, empty room suddenly alive with flashes of invisible sparks, each igniting and vanishing faster than the eye can follow. They leave no residue, no smoke, no heat, only the suggestion of presence. This is energy at the quantum level, silent, invisible, yet profoundly potent. The universe itself pulses with these transient signals, a heartbeat beneath the calm exterior of reality. What we perceive as stability is built upon countless vanishing gestures of energy, each one fleeting, each one essential. Energy's ephemeral nature raises profound questions about conservation. How can energy be borrowed and returned seemingly at will? The uncertainty principle offers a partial answer. For brief moments, nature allows deviations from classical conservation, provided they are balanced quickly. The universe tolerates temporary vanishing signals because the act of vanishing itself preserves overall harmony. This creates a paradoxical sense of order emerging from impermanence, a cosmic ballet where disappearance is as meaningful as presence. In more dramatic terms, imagine the birth of a particle-antiparticle pair in empty space. For an instant, a spark of matter emerges from nothingness. Before it can be caught, it annihilates with its counterpart, leaving only a ripple in the surrounding fields. The signal has vanished, yet its influence persists. Every moment of energy's flickering dance leaves echoes, subtle shifts that cumulatively sculpt the universe. Stars burn, planets orbit, life evolves, all against the backdrop of vanishing energy, choreographed by imperceptible pulses from the void. This principle is not confined to theory, it underlies phenomena across physics. Hawking radiation, for instance, emerges from the event horizons of black holes, where quantum fluctuations allow particle pairs to separate, with one escaping as radiation. Black holes, once thought to consume everything, are slowly leaking energy back into the cosmos through the vanishing signals of quantum mechanics. Even in regions of apparent emptiness, energy is restless, leaking, and shaping the fate of the universe. The void hums beneath apparent stillness. Philosophically, the vanishing signals of energy are humbling. They remind us that the universe is not a machine governed solely by visible gears, but a living network of transient events, many invisible to the observer. Reality is participatory, the act of observing can disturb, reveal, or conceal energy's fleeting gestures. What appears stable and continuous is, at its core, a mosaic of temporary phenomena, constantly appearing and disappearing, yet maintaining a hidden coherence. Emotionally, this challenges our perception of permanence. Everything we consider solid, lasting, and dependable, light, heat, motion, is underpinned by phenomena that vanish before comprehension. The cosmos is both predictable and ephemeral, a paradox encoded in the signals of energy. The flickering, vanishing nature of these signals conveys both awe and unease, a reminder that the foundations of existence are not absolute, but alive with restless impermanence. The cinematic close of this section envisions the universe itself as a dimly lit hall, where sparks of energy flare and vanish across the expanse. Each flash illuminates the surrounding darkness for a heartbeat, then disappears, leaving only the hint of its existence. Despite the fleeting nature of each signal, together they create a rhythm, a pattern, a coherent reality. The observer stands in the center, witnessing both the beauty and the mystery, that the vanishing signals of energy, though unseen, orchestrate everything we know. And so, the question lingers, if energy can vanish and reappear, what is truly permanent? Are the signals that shape reality lost forever, or do they persist in ways we cannot yet detect? In the quantum world, vanishing is not absence, it is the engine of existence. Information is the currency of reality, the subtle thread that weaves together cause and effect, order and chaos. In the classical world, information is clear, recorded, and transmissible. A message sent across space arrives intact, a book preserves knowledge across centuries, and data travels through circuits without ambiguity. But in the quantum domain, information behaves differently. It flickers, hides, and in many cases, vanishes entirely. When we attempt to extract knowledge from a quantum system, the very act of observation can erase the signals we seek, leaving only fragments behind. The universe, it seems, guards its secrets jealously, revealing them only under the strictest terms. One of the most dramatic illustrations of this principle is the black hole information paradox. According to classical theory, anything that falls into a black hole is lost forever. Matter, energy, even the information encoded within the particles themselves should vanish beyond the event horizon. Yet, quantum mechanics insists that information cannot be destroyed. The signals that define the identity of the infalling matter must somehow persist, even as the black hole evaporates via Hawking radiation. This vanishing and yet persistent nature of information defies intuition, creating one of the most compelling puzzles in modern physics. Imagine standing at the edge of a cosmic abyss, watching a star swallowed by darkness. The information it carried, the arrangement of atoms, the light it emitted, the energies it radiated, disappears from view. Yet, subtle imprints linger, embedded in the radiation that escapes, in correlations between particles that once had no apparent connection. The signal has vanished, yet its essence persists, hidden in a web of probabilities. The universe keeps a ledger that our eyes cannot see, a record written in vanishing signals that only mathematics and theory can begin to interpret. The cinematic weight of this paradox is profound. Picture a library in which every book evaporates the moment it is opened. Some words linger on the air for a heartbeat, some letters scatter into silence, and only fleeting fragments remain to tell the story. This is quantum information, elusive, ephemeral, yet fundamentally indestructible. Every measurement, every interaction, is a negotiation between revelation and loss. The act of knowing alters the system, collapsing possibilities into a single outcome while erasing others forever. Signals vanish as soon as they are touched, leaving behind a tapestry of absence interwoven with traces of presence. Entanglement deepens the mystery of information. Two particles, once connected, retain correlations even when separated by cosmic distances. Measure one, and the state of the other becomes defined instantly. The information is encoded in these correlations, yet no usable message travels between them. The signals are there, but they vanish when we attempt to command them. Nature allows connectivity without communication, presence without transmission. The universe whispers in riddles, and only by interpreting patterns can we recover what has seemingly disappeared. This has profound implications for computation and communication. Quantum computers exploit the delicate persistence of information in superpositions and entanglements, performing calculations across many vanished signals simultaneously. The information is neither fully here nor there, it is suspended in a liminal state, vanishing and reappearing as computation proceeds. Unlike classical computers, which store data in stable bits, quantum systems manipulate probabilities, making vanishing signals a tool rather than a limitation. What once seemed like absence becomes functional presence, a paradox that drives technological revolutions. Philosophically, the vanishing signals of information challenge our understanding of reality itself. If the universe hides as much as it reveals, then knowledge is always partial, provisional, and participatory. We are not detached observers recording an independent reality, we are entangled actors, our measurements collapsing the wave function, our choices determining which signals survive. The act of learning is inseparable from the act of altering the world. To know is to erase, and yet to erase is to create understanding. Emotionally, this uncertainty resonates with human experience. Our memories, our communication, and even our perception of events mirror these vanishing signals. Information is never complete, it is always partial, reconstructed from fragments, filtered through consciousness, and subject to decay. The universe models our own fragility. Signals come and go, vanish and persist, and in their disappearance lies both mystery and meaning. The cinematic close of this section returns to the black hole, a silhouette against a sea of stars. Light bends around it, particles swirl at the horizon, and radiation escapes in subtle flickers. Somewhere within this cosmic dance, information both vanishes and survives. The observer can measure only fragments, yet those fragments hint at a deeper coherence, a hidden ledger of reality. In this interplay between presence and absence, revelation and loss, the vanishing signals of information write the story of the universe itself. And so the question lingers: if the signals of information vanish the moment we attempt to grasp them, what truly remains? Are they gone, or are they preserved in forms beyond comprehension, whispering secrets to those patient enough to listen? Consciousness, the most intimate frontier of human experience, exists at the intersection of perception, thought, and awareness. It is the stage upon which reality is interpreted, emotions unfold, and selfhood asserts itself. Yet, when viewed through the lens of quantum mechanics, consciousness becomes a strange and tantalizing frontier, a realm where vanishing signals might play a hidden role. Could it be that the flickers, collapses, and ephemeral events of the quantum world leave traces in the patterns of thought, perception, or cognition? Are our very experiences, our sense of I, shaped in part by signals that vanish even as they shape us? The idea is controversial, yet undeniably compelling. Some theorists suggest that consciousness itself may operate at the edge of quantum processes. Neurons and synapses obey classical rules in their firing, yet the molecular machinery underlying them, microtubules, ion channels, and molecular vibrations, may display quantum behavior. Signals appear and vanish at scales too small for classical biology to perceive, yet their collective effect could ripple upward into the structures that generate awareness. In this view, consciousness is not merely the emergent property of classical computation. It is entangled with the subtle, elusive pulses of quantum reality. Imagine a thought as a wave function, existing in superposition. Multiple possibilities coexist: I will act, I will wait, I will choose another path. Only upon decision does one outcome crystallize, collapsing the superposition into a single reality. The other potential paths vanish, leaving no trace of their presence except in subtle influences on future cognition. In this sense, human choice mirrors quantum collapse. The vanishing signals of possibility give rise to a singular, lived reality, while countless alternatives quietly disappear into the shadows. Consciousness may itself be a continual navigation through the vanishing potentials of reality, a delicate dance on the edge of the infinite. Experimental evidence remains sparse, but the thought experiments are provocative. Consider the phenomenon of intuitive insight, moments when the mind perceives connections or solutions without conscious deliberation. Could these flashes of insight reflect the collapse of quantum possibilities within neural structures, fleeting signals that guide cognition before vanishing? The mind may harness what classical observation cannot see directly: the transient pulses of a quantum substrate, signals that exist only long enough to influence outcomes and then disappear without direct detection. In such a framework, human awareness becomes a lens for the vanishing whispers of the universe. The cinematic imagery of this concept is vivid. Picture a brain lit from within, a lattice of neurons firing, interspersed with faint, fleeting glimmers of light that vanish before the eye can fully track them. Each glimmer represents a possible path, a potential thought, a signal that may or may not manifest as conscious experience. The dance is relentless, invisible to the naked eye, yet foundational to the patterns of awareness, emotion, and decision. Consciousness is a theater where vanishing signals play their ephemeral roles, shaping reality while remaining largely hidden. Philosophically, this raises profound questions about free will, identity, and the nature of experience. If quantum vanishing signals influence neural activity, then the line between determinism and spontaneity blurs. Choice may emerge from a sea of fleeting possibilities, each vanishing yet collectively shaping the trajectory of thought and action. Our sense of agency might be entwined with the ephemeral rhythms of a deeper reality, a subtle interplay of presence and disappearance that underlies the illusion of continuity. Ethically and existentially, the implications are staggering. Consciousness as a participant in the vanishing signals of the universe suggests that each moment of awareness is more than passive observation. Every perception, decision, and thought may be intertwined with the quantum fabric, an active collapse of possibilities that defines both the self and the world it inhabits. The fleeting signals are not meaningless, they are the scaffolding of experience, the hidden pulse that makes reality intelligible and meaningful. Neuroscience offers tantalizing hints. Quantum coherence, entanglement, and tunneling have been observed in biological systems, from photosynthesis to avian navigation, suggesting that living systems are capable of exploiting vanishing signals for function and adaptation. If energy and information can vanish and reappear to shape outcomes in nature, why should consciousness be exempt? The human mind may simply be a particularly complex arena in which quantum transience orchestrates awareness, subtly guiding cognition through ephemeral pulses that escape direct measurement. Yet the mystery remains profound. The signals vanish before they can be grasped, leaving only traces in the structure of thought and behavior. Consciousness may be a witness to the imperceptible, a participant in a world that flickers in and out of existence at the edge of perception. In this interplay, human experience becomes a bridge between the visible and the invisible, the enduring and the vanishing, the known and the unknowable. The cinematic close of this section is haunting. A figure sits in meditation, eyes closed, surrounded by faint glows representing neural activity. Within the lattice of the mind, tiny flashes appear and vanish like fireflies in darkness, each shaping the contours of perception, memory, and choice. The signals are fleeting, elusive, yet integral. They are the silent architects of thought, the invisible hands molding consciousness itself. In the quantum theater of the mind, vanishing signals do not simply exist, they define existence. And so the question lingers: if consciousness is entangled with the fleeting signals of reality, what does that mean for the self? Are we merely observers of a deterministic world, or are we co-creators, collapsing possibilities into the singular narrative of lived experience? The answer remains hidden, vanishing as quickly as it appears, leaving only awe and wonder in its wake. Chaos is the shadow that lurks behind the elegance of physics, the unpredictable tremor beneath the apparent order of the universe. In the classical world, chaos has rules of its own, sensitive dependence on initial conditions, fractal patterns, strange attractors, but it remains bounded, a known unknown. In the quantum world, however, chaos becomes something far stranger, intertwined with vanishing signals and ephemeral possibilities. What seems random may be guided by imperceptible pulses. What seems orderly may be hiding instability that flickers and disappears before observation can capture it. The boundary between determinism and uncertainty blurs, and the signals of predictability themselves begin to vanish. Consider a system at the edge of quantum chaos, where particles interact in ways that amplify tiny variations into large-scale consequences. A minor fluctuation, a fleeting quantum event, can ripple through the system, creating patterns that appear entirely new, unpredictable, yet inevitable once they unfold. The initial signal, the origin of change, vanishes almost instantly, leaving only the chaotic result visible. In this way, the quantum world turns chaos into a theater of hidden causes and vanished signals, a ballet in which the dancers appear without a trace of their prior movements. The cinematic imagery is striking. Picture a storm sweeping across a dark landscape. Lightning flashes reveal glimpses of turbulent terrain, yet each image lasts only a heartbeat before being swallowed by shadow. This is the essence of quantum chaos. Each signal appears, hints at a trajectory, and then disappears, leaving the observer to reconstruct the pattern from fleeting impressions. The universe presents its dance in fragments, teasing comprehension, rewarding only patience and insight. Quantum chaos is not merely a theoretical curiosity, it has tangible consequences in nature. Chemical reactions, protein folding, and even the dynamics of weather can be influenced by vanishing signals at the quantum level. Tiny, fleeting fluctuations in energy or particle states propagate outward, shaping macroscopic outcomes in ways that classical intuition cannot predict. The invisible hands of quantum uncertainty guide processes that determine life and death, stability and catastrophe. The vanishing signals act like hidden conductors, orchestrating a symphony whose notes vanish before they are fully heard. One of the most haunting aspects is the role of measurement. Observation itself interacts with chaotic quantum systems, collapsing possibilities while erasing alternative outcomes. The act of watching does not merely record, it transforms. Signals vanish under scrutiny, replaced by the singular reality that we can perceive. The observer becomes both participant and disruptor, entangled in the dance of chaos, unable to witness the full tapestry without altering it. This interplay deepens the philosophical implications. Reality is not a static stage but an evolving narrative, shaped by both hidden processes and conscious observation. The interplay between order and chaos is essential to understanding the universe. While the vanishing signals may appear as gaps, as missing threads, they are in fact crucial for structure to emerge. Patterns arise not despite vanishing signals, but because of them. The unpredictable flickers, the ephemeral pulses, the moments that disappear without a trace, all contribute to the grand architecture of reality. In this sense, chaos and vanishing signals are not enemies of understanding but co-creators of complexity, shaping the cosmos in subtle, profound ways. Emotionally, quantum chaos evokes both awe and unease. It reminds us that certainty is provisional, that the signals upon which we rely can vanish without warning. The world is not merely unpredictable in the human sense, it is unpredictable at its core, constructed from possibilities that appear and disappear, leaving only traces. This instability challenges our desire for control, yet it also offers wonder. The universe is a dynamic, living entity, its patterns emergent from the interplay of visible and vanished signals, of presence and absence. Philosophically, chaos at the quantum level forces a reconsideration of causality. If the seeds of large-scale events vanish almost as soon as they arise, then what does it mean to assign responsibility, predict outcomes, or understand processes? The universe does not provide guarantees, it provides fleeting cues, hints that must be interpreted, reconstructed, and integrated into understanding. In this way, vanishing signals are both frustrating and enlightening, emphasizing the participatory nature of observation and the provisional quality of knowledge. The cinematic close of this section is vivid and haunting. A vast, stormy expanse stretches across the screen, lightning revealing fleeting glimpses of jagged terrain. Tiny sparks flicker across the ground, ephemeral signals of underlying forces, vanishing as soon as they appear. A lone observer watches, notebook in hand, struggling to map the chaos, aware that every insight gained erases other possibilities. The storm rages, patterns emerge and vanish, and the signals that might have explained everything are gone, leaving only the unfolding drama of unpredictable beauty. And so the question remains, in a universe guided by vanishing signals and quantum chaos, how much can we truly predict? How much can we truly know? The answer lies not in certainty, but in the dance itself, in the fleeting glimpses of order among the ephemeral pulses that shape reality. In the quantum theater of chaos, what vanishes is as significant as what appears, and the rhythm of disappearance becomes the pulse of existence itself. The boundaries of reality are never as solid as they seem. Every step forward in science reveals layers of complexity, interwoven with vanishing signals, elusive particles, and fleeting phenomena that challenge our understanding. In the classical world, we are taught to trust our measurements, our instruments, and our observations. But in the quantum domain, certainty is a fragile illusion. Signals that we expect to persist often vanish the moment we attempt to capture them, leaving us with tantalizing fragments that hint at a deeper structure of reality. This is the frontier where physics meets philosophy, where the visible universe is only the surface of a far stranger truth. Consider the role of measurement itself. In quantum mechanics, observing a system is not a passive act, it is an interaction that collapses possibilities into a singular outcome. Before measurement, particles exist in superpositions, as clouds of potentialities. The signals of their state are diffuse, spread across multiple possibilities, vanishing and reappearing as probabilities. Only when observation occurs do we see a defined reality, but in the process, countless alternative signals vanish, leaving no trace of the other paths that could have been taken. The act of knowing is inseparable from the act of erasing. This phenomenon is captured dramatically in the thought experiment of Schrödinger's cat. Inside the box, the cat is both alive and dead, its state is superposition of two possibilities. The signal of its true condition exists in a liminal state, vanishing and returning, dependent on the act of observation to crystallize. When the box is opened, one outcome appears and the other disappears from the accessible universe. The vanished signal is not lost, it persists mathematically, but it is inaccessible, a ghost of a reality that might have been. Such examples reveal how profoundly quantum mechanics reshapes our intuition about existence, presence, and absence. The cinematic imagery of vanishing signals at this stage is compelling. Picture a dark room filled with countless glowing orbs, each representing a potential outcome, a quantum possibility. As an observer moves through the room, some orbs flare into bright, observable light, while others vanish silently, their presence acknowledged only in the briefest flicker. The room itself seems alive, a space of perpetual emergence and disappearance, a visual metaphor for the ephemeral signals that construct the universe. Each vanishing pulse is both a loss and a revelation, a hidden note in the symphony of reality. Entanglement amplifies the mystery further. Two particles can be linked across space in such a way that the measurement of one instantaneously defines the state of the other. The signals connecting them are non-local, invisible, and resistant to classical interpretation. Yet when we try to extract usable information, the signals vanish into correlations that cannot be commanded or transmitted. The universe allows connectivity without communication, presence without agency. The vanishing signals are a reminder that reality operates on rules far beyond human intuition, that the web of existence is woven from threads we can perceive only partially. Philosophically, the implications are profound. Vanishing signals suggest that reality is participatory. The universe does not simply exist independently of observation, it interacts with the act of perception. Knowledge and being are intertwined. To witness is to influence, to measure is to define, and to attempt to extract information is to erase alternative possibilities. The world is a dialogue, not a monologue, a continuous interplay between presence and absence, visibility and disappearance, signal and silence. This has emotional weight as well. Humans crave stability and predictability, yet the quantum world offers neither in full measure. We are confronted with a cosmos where the signals we rely on are ephemeral, vanishing before comprehension, yet their disappearance shapes everything we experience. There is awe in this revelation. The universe is not static, but dynamic, creative, and constantly renewing itself through processes we can glimpse only fleetingly. Every vanished signal is a whisper of the hidden order, a suggestion of the profound intelligence embedded in the fabric of reality. In practical terms, vanishing signals have reshaped technology. Quantum cryptography, quantum computing, and precision measurement all exploit the ephemeral nature of information. Signals that disappear when observed cannot be intercepted or tampered with, providing security and computational power beyond classical limits. What was once perceived as a limitation, the vanishing of signals, is now a tool, harnessed to expand human capability and understanding. The fragility of reality itself becomes an instrument of progress. The cinematic close of this section paints a haunting picture. A physicist stands before a complex apparatus, screens aglow with data. Each signal that appears is immediately followed by the disappearance of another, like echoes fading in a vast chamber. The room hums with invisible activity, patterns emerging and vanishing faster than the eye can follow. The observer is both awed and humbled, aware that the vanishing signals are not failures, but the very pulse of the universe, signals that vanish to create the reality they define. And so the question lingers, what truly exists when signals vanish? Are these ephemeral pulses merely shadows of reality, or are they the fabric from which reality itself is woven? In the quantum theater, disappearance is as fundamental as appearance, and the vanishing signals tell the story of existence in a language that we are only beginning to understand. The final frontier of understanding lies in the synthesis of everything we have glimpsed, the vanishing signals of quantum reality, the ephemeral whispers of time, space, energy, information, and consciousness. As we approach the limits of observation, the patterns that emerge are both exhilarating and unsettling. Reality is not a static tableau but a dynamic interplay of presence and absence, a universe written in pulses that appear and vanish, guiding existence even as they elude capture. The signals we chase are fragile, often fleeting, yet they are the scaffolding upon which the cosmos is built. To witness their vanishing is to peer behind the veil of stability and glimpse the raw processes that animate all things. Imagine standing on the edge of a vast canyon, the wind carrying faint echoes of what once was, and shadows stretching endlessly below. Each shadow is a vanished signal, a transient phenomenon that shaped the landscape but no longer exists in its original form. The canyon is alive with these traces, a layered narrative of presence and disappearance. In the quantum universe, this is the reality at every scale. From subatomic particles to the largest cosmic structures, vanishing signals guide interactions, create coherence from chaos, and shape the emergent world that humans perceive. The echoes of what has vanished are everywhere, subtly orchestrating the symphony of existence. The cinematic contrast between what we observe and what vanishes is striking. Consider a galaxy, rotating majestically in the depths of space. Every particle within it is influenced by vanishing quantum signals, interactions so fleeting they escape direct measurement, yet collectively they stabilize the structure we see. Without these ephemeral processes, the grand forms of stars, planets, and galaxies would not hold. What is visible is built upon what is invisible, what persists arises from what vanishes. This interplay between presence and absence creates a tension that is both beautiful and humbling, emphasizing that the universe is far richer than our senses or instruments alone can reveal. Philosophically, the implications are profound. Vanishing signals challenge our deepest assumptions about reality, causality, and permanence. The universe is not a deterministic machine, it is a network of possibilities, many of which are erased as others are realized. Each vanished signal contributes to the emergent order, defining outcomes even as it disappears. This suggests that reality is participatory. Observers, systems, and events interact in ways that collapse possibilities, select outcomes, and erase alternatives. Existence itself is a dance between what appears and what vanishes, a continuous negotiation between the ephemeral and the enduring. Emotionally, confronting the vanishing signals evokes both awe and humility. We are reminded of our limited perception, the transient nature of certainty, and the profound creativity of the cosmos. Every moment we experience, every phenomenon we observe, is a product of countless fleeting signals, orchestrating the universe with a precision and subtlety that surpasses human comprehension. The vanishing is not absence, it is a silent architecture, a hidden framework that enables the richness of life, thought, and cosmic evolution. Recognizing this transforms wonder into reverence, as the universe becomes not a static backdrop but a living, breathing entity of ceaseless emergence. Technologically, the harnessing of vanishing signals represents a revolution in human capability. Quantum computing relies on the manipulation of ephemeral states, exploiting superpositions and entanglements to perform calculations that classical systems could never achieve. Quantum cryptography leverages the disappearance of information upon observation to create unbreakable communication channels. Even in biology, ephemeral quantum processes guide energy transfer, photosynthesis, and navigation in ways previously unimaginable. What was once invisible and fleeting has become instrumental, demonstrating that vanishing signals are not merely curiosities, they are tools that define and expand our understanding of the possible. The cinematic imagery for this synthesis is breathtaking. Picture a vast dark expanse, dotted with ephemeral sparks that appear and vanish, each pulse interacting with others to form fleeting patterns of light. Slowly, these patterns coalesce into recognizable forms: galaxies, star systems, molecular structures, and neural networks. The viewer perceives a universe emerging from the dance of signals, built upon the fleeting and transient, stabilized by disappearance itself. Every vanishing pulse is essential, each ephemeral signal a brushstroke in the cosmic painting, invisible in isolation yet vital to the whole. Finally, this section closes with a reflective, almost meditative note. The vanishing signals of the quantum unknown are not merely scientific curiosities, they are philosophical provocations, emotional experiences, and practical tools. They remind us that certainty is provisional, that existence is participatory, and that the cosmos is far more intricate than the eye can perceive. By observing, interacting, and understanding, even partially, we become part of the unfolding narrative, witnesses and participants in the subtle choreography of reality. And so the ultimate question persists: if reality is written in vanishing signals, what is the nature of being itself? Are we mere observers of fleeting pulses, or are we co-creators, shaping the emergence of existence with every act of measurement, choice, and awareness? The answers remain tantalizingly out of reach, slipping away like the very signals we strive to comprehend, leaving only wonder, curiosity, and the unending pursuit of understanding. The pursuit of understanding the vanishing signals of the quantum unknown brings us to an even deeper and more philosophical threshold: the nature of reality itself. Across centuries, humans have sought certainty, a universe that is predictable, measurable, and orderly. Classical physics provided comfort: the clockwork universe, the steadfast march of time, the reliable behavior of matter and energy. Yet the quantum world shatters this comforting vision. Signals vanish, particles exist in superpositions, entanglement defies distance, and possibilities flicker into existence only to disappear. Reality is revealed to be far less rigid than previously imagined, far more fluid, and far more mysterious. Each vanished signal is not simply a loss but a hidden architect, shaping the universe in ways that remain imperceptible to direct observation. Imagine standing at the edge of creation itself. The cosmos stretches endlessly before you, filled with galaxies, nebulae, and stars, each a testament to the structures that emerge from invisible and vanishing quantum signals. Within this grand expanse, the fundamental rules of existence are not written in stone but in fleeting pulses of possibility. Particles dance between states, energy flickers into and out of the vacuum, and even the fabric of space and time trembles with uncertainty. The very architecture of the cosmos depends on the ephemeral, the transient, the signals that vanish before they can be fully grasped. The universe, in essence, is a work in perpetual progress, constantly emerging from disappearance. At the most intimate level, human perception itself is intertwined with this elusive reality. Our consciousness experiences a world that seems stable, continuous, and predictable, yet the underlying quantum events that scaffold perception are themselves ephemeral. Every sensation, every thought, every choice is a collapse of multiple possibilities, each of which vanishes as the selected reality emerges. The mind becomes both observer and participant, a bridge between the visible world and the vanishing substratum beneath it. In this way, consciousness is not merely influenced by vanishing signals, it is shaped and structured by them, an emergent phenomenon riding the ephemeral tides of reality. The cinematic imagery here is hauntingly beautiful. Picture a vast hall of mirrors stretching infinitely in all directions, each reflecting countless possibilities, each reflection flickering and vanishing as you approach. Some images sharpen into clarity, while others disappear entirely, leaving only whispers of their existence. This whole is the universe itself, where every signal that emerges carries the weight of countless vanished alternatives. The dance of appearance and disappearance is constant, mesmerizing, and disorienting, reminding us that the universe is not a static stage but a fluid, participatory creation. Quantum entanglement magnifies the mystery. Particles separated by light years behave as if connected by invisible threads. A measurement of one instantly determines the state of another, yet the signal connecting them is not a signal in any classical sense. It cannot be intercepted, delayed, or predicted. The connection exists outside traditional notions of space and time, a vanishing signal whose influence is real but inaccessible. These phenomena suggest that the universe is not merely local but woven from a network of interconnections that transcend ordinary comprehension. Reality, in this sense, is not a collection of isolated objects but a relational web, constructed as much by disappearance as by presence. Entropy and the arrow of time add another layer of intrigue. Classical thermodynamics assures us that entropy increases, that systems move from order to disorder, that the past is fixed and the future uncertain. Yet at the quantum scale, this arrow wavers. Signals of time itself can flicker, vanish, and loop back in ways that challenge linear causality. The past may not be immutable, the future not preordained. Our perception of cause and effect relies upon the aggregation of vanishing signals into emergent patterns. Time, once thought absolute, is revealed as a tapestry woven from the ephemeral, the transient, the signals that appear and disappear. Philosophically, this suggests that the universe is participatory at its core. Observation is not passive, it is a creative act. The vanishing signals of quantum reality imply that existence is contingent upon interaction, that knowledge and being are intertwined. The universe is less a pre-written script and more a collaborative improvisation, where the act of engagement, the measurement, the observation, the decision, shapes what emerges. The signals that vanish are not errors or gaps, they are the mechanism by which possibility is filtered into actuality. Each disappearance is a shaping force, sculpting the universe as surely as any visible event. Emotionally, confronting this reality is both humbling and exhilarating. On one hand, it destabilizes the certainty humans crave, revealing a cosmos where even the most fundamental signals can vanish without warning. On the other hand, it imbues existence with profound wonder. The universe is not static but alive, constantly emergent, infinitely rich, and far more intricate than our senses or instruments alone can capture. Every vanished signal is a hidden architect, a subtle note in a symphony that spans scales from the subatomic to the cosmic. Recognizing this transforms fear into awe, chaos into beauty, and disappearance into a source of creative potential. Technologically, harnessing vanishing signals has transformed human capability. Quantum computing exploits ephemeral superpositions, performing calculations across states that vanish before observation. Quantum cryptography leverages the disappearance of signals to create secure channels of communication. Even in biology, fleeting quantum events underpin processes from photosynthesis to navigation. What was once an enigma, the vanishing of signals, is now a resource, a tool, and a key to understanding the universe on a deeper level. The ephemeral is functional, the fleeting is foundational, and disappearance becomes a driver of emergence. The cinematic close of this section is awe-inspiring. A panoramic view of the cosmos unfolds, galaxies spin, nebulae glow, and particles flicker across the void in ephemeral brilliance. Invisible forces shape the dance, unseen yet essential, vanishing signals orchestrating patterns of unimaginable complexity. A lone observer floats in this cosmic sea, watching, comprehending only fragments, aware that what is missing is as vital as what is seen. The universe pulses with fleeting possibilities, and in their disappearance lies the rhythm of all existence. And so, the ultimate reflection emerges. The vanishing signals of the quantum unknown are not merely scientific curiosities, they are the pulse of reality itself. They shape space, time, energy, information, consciousness, and chaos. They are the unseen architects of the cosmos, the ephemeral threads from which existence itself is woven. In a universe built upon disappearance, we are both witnesses and participants, observers and co-creators, experiencing a reality that is as transient as it is eternal, as fleeting as it is infinite. As we reach the final frontier of this journey into the vanishing signals of the quantum unknown, the mind grapples with a vision of reality that is both beautiful and bewildering. Throughout the cosmos, from the smallest subatomic particles to the largest galactic structures, the signals that define existence are fleeting, ephemeral, and elusive. They flicker into being only to disappear, shaping the universe in ways both subtle and profound. The very foundation of what we perceive, space, time, energy, information, consciousness, and chaos, is constructed upon the ephemeral pulses that vanish before we can fully grasp them. To understand the universe, we must learn to navigate a reality built upon absence as much as presence, a world where disappearance is not loss but creation. Imagine floating in the void of space, surrounded by countless stars and galaxies, each a monument to the interplay of forces that emerge from vanishing signals. At every scale, imperceptible processes are at work. Particles appear from the vacuum, interact, and vanish. Energy flickers across distances, shaping fields and structures. Information emerges, disperses, and reconfigures in ways that defy classical intuition. The cosmos is not a static arena but a living network of ephemeral events, a dynamic choreography of presence and absence. Each vanished signal contributes to the architecture of the universe, creating coherence from transience, stability from impermanence. Cinematically, the imagery is staggering. Picture a dark expanse dotted with countless points of light, each representing a fleeting quantum event. Some pulse and vanish instantly, others linger just long enough to influence their neighbors, forming temporary constellations of interaction. Slowly, the patterns coalesce into familiar structures, swirling galaxies, stellar nurseries, planetary systems, and, finally, the delicate lattice of life itself. The audience senses that what is visible is only a fragment of the greater whole, and that every observable phenomenon is anchored in a foundation of vanished signals, imperceptible yet essential. At the human scale, these vanishing signals resonate deeply. Our consciousness, perceptions, and choices emerge from networks of neurons, synapses, and molecular interactions, many of which may exhibit quantum behaviors. Thoughts crystallize from a superposition of possibilities. Decisions collapse fleeting probabilities into lived reality. Memory and perception are sculpted by processes that flicker in and out of existence, forming a continuity that is fragile, provisional, and emergent. In essence, human awareness mirrors the universe at large, constructed upon ephemeral signals that vanish even as they shape our experience. Entanglement, superposition, and tunneling, the hallmarks of the quantum world, permeate every level of existence. Particles separated by vast distances remain linked, instantaneous connections forming despite the void between them. Energy fluctuates in the vacuum, driving processes from the atomic scale to cosmic evolution. Information emerges, persists, and vanishes in a delicate balance, sometimes leaving traces in correlations that can only be interpreted mathematically. These phenomena remind us that reality is relational. The universe is defined as much by interactions that disappear as by objects and events that persist. Presence and absence are inseparable partners in the cosmic dance. The philosophical implications are profound. The vanishing signals of the quantum unknown challenge our deepest assumptions about causality, permanence, and knowledge. Reality is participatory, observation is not passive, but a co-creative act that collapses possibilities, erases alternatives, and defines outcomes. What disappears is as important as what appears. Absence is a shaping force. In this framework, the universe is a living, emergent system, where every interaction, every act of measurement, and every fleeting event contributes to the unfolding story. The ephemeral pulses of existence are not failures or gaps, they are the mechanisms through which order, complexity, and consciousness emerge. Emotionally, confronting this truth is both humbling and exhilarating. It destabilizes our craving for certainty, revealing a cosmos in which even the most fundamental signals can vanish without warning. Yet it also inspires awe. The universe is infinitely richer, more intricate, and more beautiful than our senses alone can perceive. Every vanished signal is a hidden architect, a subtle note in the symphony of creation. Understanding that reality itself is constructed from disappearance transforms fear into wonder, impermanence into possibility, and uncertainty into reverence for the complexity of existence. Technologically, human ingenuity is beginning to harness the vanishing signals that were once considered beyond reach. Quantum computers exploit ephemeral superpositions to perform calculations impossible for classical machines. Quantum cryptography leverages the disappearance of information upon observation to create unbreakable channels. Biological systems, too, exploit fleeting quantum events for navigation, energy transfer, and molecular function. The ephemeral is no longer a limitation, it is a tool, a medium through which understanding and capability expand. The vanishing signals are at once the challenge and the solution, a source of insight and a driver of progress. The cinematic close of this final section is both awe-inspiring and contemplative. A lone observer floats in the vast expanse of the cosmos, surrounded by galaxies and ephemeral bursts of light that flicker and vanish like quantum sparks. Each pulse contributes to the unfolding structures around them, stars, planets, life itself. The signals vanish before they can be fully comprehended, yet their influence is undeniable, forming the very fabric of reality. The observer realizes that the universe is not merely observed, it is experienced, participated in, and co-created through the interplay of presence and disappearance. In the final reflection, the vanishing signals of the quantum unknown reveal the paradoxical nature of existence. Disappearance is creation, absence is structure, and impermanence is the foundation of reality. They remind us that the universe is a living, breathing network of ephemeral interactions, and that human experience, consciousness, and understanding are part of this dynamic tapestry. In embracing the vanishing, we glimpse the hidden order of the cosmos, the subtle choreography of reality, and the profound beauty of a universe in which what disappears is as meaningful as what persists. And so the ultimate contemplation emerges. If existence itself is constructed from vanishing signals, what is the role of humanity in this unfolding narrative? Are we passive witnesses, or active participants, co-creators in a cosmos built upon the ephemeral? The answers remain elusive, slipping like the very signals we strive to understand, leaving only wonder, curiosity, and the profound recognition that reality is far more wondrous than our minds can fully grasp.